Good evening, everybody. Let us wait for another 2 or 3 minutes. Still, some people should join. In the meantime, I was checking some of your homeworks. Chinmay, you have done excellent, and I want to know that I think you are somebody is speaking. Chinmay, can you please unmute?
Yes, sir.
Yeah, I was seeing your codes.
Yes, sir.
Yes, so Chinmay, I was seeing your codes. It is nice. You have done it in a very nice manner and in an advanced manner. Good.
Thank you, sir.
Yeah. Others, many of them have not sent the homeworks. I got only Chinmay, Gayatri, Geeta, Jovita, L. Priyanka, Priyanka Mukhia, Rajapriya, Shruti, and Shravani. For others, why there is no homework from you? And most of you have not read the data from the Excel sheet. Why? What was only, I think Chinmay has only read it from the Excel sheet. And others, was it so difficult? Because I know anyway that you can create a data set, but I wanted you to read from the Excel sheet. See, it is not so simple. I will just share the screen. Before that, I will download the data set and I will show you how to do it. And nobody responded also said it is not happening. Why it is not happening? I wanted to know that. Okay, you all can see my screen?
Yes, sir.
Yeah. So you have to do little bit of data editing here only. If you then it would have been better. Better in the sense you could have read it. See directly this also you could have read it. Only thing, if you are deleting it, it will be easy for you to understand. This is one, and one thing is here heights. Like this, if you are doing it, then it will be easy for you. Otherwise, I don't know why nobody has read it from the Excel sheet. Alex, what is your homework assignment?
Actually, I had no idea what I was supposed to do, sir. I forgot.
I told you only send this data set. I told you to read it in your R.
After reading, what am I supposed to do, sir?
Huh? At
After
least
reading the
at least that you could have done it, no? At least that only you could have done it. That's what I was waiting for anybody. But so far, no, except Chinmay, nobody has done that. Because I wanted you to read this data set and do some executions, whatever is possible. Okay, this is to some extent your data in a better manner. So you can save it. So I can make it like responses for. Okay. So let us treat it in R. Okay. So see if the directory is finally set. So you can give either a single quote or double quotes. It is up to you. What is the name I gave? Responses for. Okay. .csv. So is the code right, everybody? Just check it out, everybody, the code. So data, you are reading the table, that is the rest name I gave, RESPON SES, RESPON SES dot CSV, header equal to T, sept, you have given as comma. So you can read it and see if there is any, if there is no mistake, it will read it. So it has successfully read your table. So let us see what is your data content. See, like this I wanted you to read the data, which many of you has not done it. I don't know why. Then suppose if I ask you to just to give the mean of male weight and male height and female weight and female height, how can you do it? Anybody? What code can you use? Anybody? Anybody can speak out? Just if you can type here only the weight, individual weight. How can you do that? Data dollar weight. So it has come already directly. So data weight and data height. So now it will be easy for you to calculate the individual mean. Individual in the sense that either for the male or the female. So what command will you use? Anybody? Anybody? How will you do it? Which command can you use?
Mean of data dollar weight.
Yeah, no, how, which command you will be using? Mean, yes, so definitely you have to calculate the mean. But how will you do it? Just to calculate the mean of female weight and male weight separately. Then which command will you give? Last day I told you which command. Why you all are silent? T-apply you can give. T-apply. Then you can give as weight and gender. Data of weight. Comma. Data dollar. Gender. Comma. Right? Is the same command did I tell you last day? Yes or no?
Yes, sir.
Yeah. So now see what is happening. So give your X. So female mean and male mean for weight. In a similar manner, you can do for the height. So 2 or 3 codes I had asked you to do it. So this is T apply. Instead of data weight, you can give as data height. That's it. Data gender and then make it Y. And this is Y. That's all I had asked you to do. Now separately you can do some other some other things using the this one data sets. so many things I have told you. At least I just wanted everybody to read from the responses. Okay, did you all understand it?
Yes, sir.
Yes, sir.
Okay, then let us move on. Those who want, you can take these codes. If you want, you can take these codes. Mainly is this one, this code, because this is the what I wanted to do it. I wanted you to read this file because from the next class onwards, maybe on from Sunday or next week, you have to read only the datas. Then it should not be a problem for you. Okay, let us move on. Okay, okay. Okay, this is where the last day I had stopped. Okay. So next is a special type of fonts, how you can get it. That is firstly fonts. It is a special type of font which is like vector fonts that greatly extend the range of characters and symbols which are available. In contrast to the regular bitmap fonts that consist of a set of small images, one for each character of each style and size. Vector fonts consist of the coordinates of each of the curves required to create the character. So these are the Hershey fonts, and you can so you can use this and get the Hershey fonts in your system. So you can just type this command and you can see it. What is coming? So are you all able to see this? Or you can do this in your R?
Yes, sir.
Okay. Okay, so these are your Hershey fonts. Okay. So next command like how you can orient and justify your text in the R. So the orientation and justification of the characters and the strings are also under the control of set of graphics parameters. So these are the graphic parameters here. So you have this ADJ function and CRT and SRT functions. So like if you do it ADJ 0, it will be like exactly in the center, and how if you are moving it ADJ 0.5, you can see the text has moved slightly like that. So you can execute it in the subsequent commands. Okay, now this is the color command. The color of all the plotting elements is controlled by a set of parameters. The default color for plotting element is specified using the call, that is COL, stand for the color parameter. There are also separate parameters that control the color of each major components of a figure. Example like color of axis, and then you have color lab, color main, that is COL main, COL sub, and when specified, take the precedence over the COL parameters. So, so let us see what are the how many colors are there in R. So these are, you can see here, 655, 656, 657 colors are there specified in your R. Just check it out if it is increased for your other version of R. Anybody is using, did you all give this command? You can check it out how many commands of colors are there.
Same, so 665.
Yeah, 665 is here.
650.
655, 656, and 657. Okay, these are the various colors are there in your R. Okay. So to take this command and run it in your R. Wait, I will give you in your chat box. So execute this.
657, sir.
Yeah, execute this. I have sent it in the chat box. So how you can change it? Here I have given that COL 8. Then you have gray 50 and gray 90. So can you change it and see if it is changed or not? Try to change the colors and see. See, you have color 8. Instead of color 8, if you want this tomato color, that is 634. Give here as 634. Okay. then it is given as gray 50. Why you want gray 50? Give it like tomato 1. Change it and see it. Then you can make it like wheat 1. Wheat 1. Okay, let it be wheat 1 only. Which is BYT, you can remove BTY, you can leave it. Delete it. See if there is any changes or not. Okay, so can you see the changes in the plot?
Yes, sir.
So you can, this is how you can change the colors in your R. There are around 657 colors. You can change the, you can use the various codes and you can change it. So I think now you are understand. First, now before that, I will show you this norm functions before moving forward. So this is you can now know this is X lab predator, Y lab response. Color is 634. 634 is given. This is tomato 1, and that color then you have wheat 1 as the x-axis color. So everybody has got it. Are you all doing it along? Are you all doing
Yes.
it?
Yes.
Yes. Okay, great. So before going ahead, I will just show you this normal and nominal and other functions so that later it will not be time. Okay. I'll just show it, then I will move with the codes. So normal functions already I had told you other day. So if you want log normal functions, log normal, what it will do, it will generate 5 random numbers from a log normal. It is a distribution whose normal has a mean of 2 with a standard deviation of 1. That is how what the command it is. I will give you now. This is for the log normal. So this particular command signifies that it will generate 5 random numbers whose distribution of which has a mean of 2 and standard deviation of 1. So mean is 2 and standard deviation as 1. So execute in your R. Okay, this is your log normal. Because these will be, you will be getting it frequently. Next is your uniform. Did you all get it?
Yes, sir.
Yes,
Okay.
sir.
Okay, next is your uniform. Here also you will this will generate 5 numbers with a distribution of 2 and minimum of 10. Sorry, maximum of 10. This is your uniform numbers. Next is Poisson distribution. Poisson distribution, the code will be R pos. So in this also it will generate 5 numbers with a lambda parameter of 4.
So if you don't mind, can you even type the codes in the R? Because when we check the YouTube videos, it won't be available that time.
Sorry, I am typing it here in the console
But it is in
rather.
the chat box, no?
Oh, you want it in the, okay, in the R codes.
Ask
Okay,
it also.
fine,
Yeah.
fine.
That's
Okay, I'll do that. What is the error here or voice function? Error, I have to check it out. What is the error coming here? Okay. Next is your binomial, and this all we will be dealing in the what this one by this one that when I will giving the biological data. That time we will be seeing in a broader manner all these functions. So for this R binomial, it is again, it is a 5 random numbers with a distribution of maximum of 5 with a probability of 4. It is coming in the binomial numbers. This person I have to check it out. There is some error coming. I have to check with the code. I will let you know why it is error is coming here. Okay. So let us move on. So colors, everybody got it?
Yes, sir.
Yes, sir. Yes,
Okay.
sir.
Okay. Okay. Next is enhancing and customizing plots with the plotting functions. Okay. So then you can add some points using the points function. This is one more parameters for this graph. So points can be added to the plot using the points, that is x, y, PCS and our functions. This function plots a plotting character specified by the PCH parameter and the coordinates specified by the vectors x and y. Alternatively, the coordinates can be passed as a formula in the form of the y is to x. So this is one command. Sorry, this one R code. You can take it and you can execute it. And before executing, please go through the command. This is very simple command. Whatever the functions are given here, it is all told in the last preceding classes. You can please check it out. So I'm sharing you in the chat box. So the plot created is the empty plot, and then you are giving the items in the plot. So if you want, you can change the values of your x, y, x, y, y1, x, y1 and y2, and you can see the reference. The PCH also you can change the values and you can see it. And I think everybody knows what is this type B. Type B is a line. In the first slide it was there. The type B was line. Do you all get it?
Yes, sir.
Everybody got it?
Yes, sir.
Okay. So let us move on. So next is adding text within a plot using the text function. So using the text function, you can add text strings with the labels as defined. So here you can give a continuous text and it will be taken by the R. So example, these are several text parameters you can use like position, offset, v font and so on. So see how it will be taking it using a code. Wait, paste function already. After the paste function, this is there. The code is there. So paste function already you have used it for concatenating two variables. Other options, other usage of this paste function is you can even add two optional parameters, set and collapse, which define extra character strings to be placed between the strings joined, and set operates on the joint between pair vectors elements, whereas collapse operates on the joints of the elements within a vector respectively. So here is your code. So whatever is within this is your text. Okay, you can take it. This is very simple functions given here. This is
We are getting it, sir.
Hmm?
We are
Sorry?
getting it, sir.
Yeah,
We are
yeah,
getting.
yeah, to do it. Very simple, because just it is the uses of the paste function. This is paste along with sep and collapse. So sep, as you know, everybody is using the sep command. It will come within this values and collapse between the variables. So this is your paste function along with the codes or the text. Please understand and execute. You can see the text function, understand the text function, and then please execute. It is given in very simple manner. This is one of the most simple codes I am giving to you. See here you have the even the color codes are given here. Then you have the text. So I think you know the CEX and POS. So you can correlate and check it out if the position is right or wrong. And PSH 16, I think PSCH 16 is giving the same dot for everybody. If you want, you can change the gray color, PCH color, and other parameters and see it if it is coming the same or not. Got everybody?
Got it, sir.
Okay.
Yes, sir.
Okay. Are you understanding the commands? It is just given with the all the functions which is given in my PPT here. Okay, one moment, everybody. One moment. Okay, next are the non-character arguments. So sometimes you will be getting some objects which should be passed as level of the object. Hello, yeah.
I'm so sorry to interrupt. What was the purpose of last command, sir?
Which one?
The last command which we executed.
Oh, one moment. Yeah, that is the text command. This one, right?
Yeah, sir.
Text x and y, you are given the x and y values are given, so you are pasting it. The site is pasted at 1 to 5, 1:5. So site 1, site 2, site 3 with a set that is between the site and one. This so this dash will be there, and CEX and POS you will be telling me what is the position, what is CEX and what is the POS. That is the position.
Okay, sir.
Okay, that is what is the text. In the text you can give the several text parameters together, but the problem is that if you are just writing it separately, like if you give in this manner, like x equal to, if you are giving it, it will be, nothing will come as such directly.
So here we are able to give color also.
Yeah, color is given. No, even here also you can give the color, but here specifically you are giving the color for the points.
Okay.
So the thing is that when this text you are giving separately, you are giving null. You see it? That is what one nicely you have told me. If you are giving that x separately, you will be getting as null. There is nothing in that. Only the text function is used only in the plots. Nice
Okay,
that you interrupted to me.
Okay, sir.
Yeah. Remember it, whenever you are giving the text function, the problem is it will not return any arguments. If it is not in a plot, it will give an error. That's all. Okay.
Got it, sir.
This is the these plots are the most important when you are, as I told in the last class, for writing any research papers. This will be very useful. Okay. So as I was telling that if you want to add some non-character arguments, it will be, they will be evaluated before being coaxed into a string for plotting. In doing so, the output of the other functions can also be plotted. So what is this? You see here. It's shared, yeah. So what happens here? You can see you are plotting it. First line and second line, you are understanding it. See text what it is adding and see one by one. They see how it is getting in your plot. This is one of the very interesting scripts of our here. Understand each line, then you execute. These are very simple commands. Understand each line and execute. So first line it is plot. So it will be giving you an blank plot. It will create the first line. Then you are giving text. Then you have something. What is the something I want to know from you? You can see here at the position 0.5 and 0.75. 0.5 and 0.75. This argument is created 5 into 2 plus 3. 5 into 2 is 10 plus 3 is what is 13 at CX. I think you know what is the CX. Okay, next you do this one text. Point 0.5 is in the x-axis. Y-axis we have changed it little bit. Initially it was 0.75. Now it is 0.5. What is it? You are giving the mean of 2, 3, 4, 5. What is the mean? You can calculate and check it out. It should be 3.5. Okay. And then finally, txt, you are pasting mean. So mean, and there is one mean equal to is there. It is pasted here, and you can give the 3.5. See, one of the interesting scripts here. So you have to individually run the command to get this. All are getting this? Anybody has any doubt? Anybody is having any doubt?
No, sir.
Okay. Please understand the values within the text. The lines are very interesting. Only condition is that if you understand. Everybody got it? Everybody got it?
Yes, sir.
Okay. Okay, next is adding text to plot margin. So plot margin, when you are adding, you are using the command mtext. Mtext for adding text to the plot margin. So mtext function adds text to the plot margin and is typically used to create fancy or additional access titles. The mtext function is given in this manner. Here you will not understand much, but if you go to the commands, you will understand. So this is how you can give the parameters like side, line, outlier, at. The parameters you can give it. And one more is ADJ, PADJ. Okay. Next, adding a legend. The legend function brings together a rich collection of plotting functions to produce highly customizable figures legend in the a single column. So these are the several legend arguments. So you have legend, title, BTY, you have box, IITY. These are the ones you are executing the commands, you will all come to know. Okay. In addition to the usual methods for specifying the positioning coordinates, convenient keywords reflecting the four corners, that is bottom left, bottom right, top left, top right and boundaries, bottom left, top right, or the plotting region can be alternatively specified. Okay. Next is the expression function. So expression function is used to build complex expression that incorporate, if it is like TX, it will be like in a haphazard manner. So like that it is like a mathematical formatting. Hence the expression function is typically nested within one of the plotting functions to plot complex combination of characters and symbols. The expression function is useful for generating access styles within complex units. The express function is also useful for plotting complex mathematical formula within the plots. Check it out here. Try to understand it line by line. See, you have here x and y. It is in that is a normal distribution. Plot. This is the plot function. Then you see here text 9.3 comma 10. Expression you have. You just check it out how it is coming one by one, rather than I tell you. I did not give it, no. This is also very interesting function. Sorry, interesting code. So set text, set seed, x norm, y norm, plot. So you are getting plot in this manner. Next, see here very nicely the text function. So you are getting a function here. So what is the function fy? Fy is given here. So in the text you have expression fy equal to, you can see double equal to is given here, that is why it is equal to fraction 1, then it is square root. You can see square root 2 into pi sigma square. Okay, into is here, into expression, that is e fractional. Then you have minus y minus mu square a comma that is dividable, then 2 into sigma square. Did you check the expression, everybody?
Yes, sir.
Everybody understood because how it is given. So you can now know in this like how you can give the square root, sigma, mu, and all and factorial. Understood, everybody? It is
Yes.
given very nicely here. Everybody got it? Everybody got it? Okay. So this I think should be the last function for today. Then I will continue again tomorrow. Okay. Next is the B code function. So what is this B code function? It generates a language object by converting the arguments after evaluating any objects wrapped in the bracket. This provides a way to produce text screens that combine mathematical formatting and output statistical functions. Here remember there is one correlation function. Correlation I did not take for you. Just you can ignore this, and because it is correlation is coming here. I think everybody might have done correlation in your statistics. So you can understand because correlation I will take separately when I will be taking the correlation part. So for now you can just skip this line and see what is the output you are getting. Because this is just I want to explain the plots to you. So please ignore some of the mathematical functions. Until and unless I come specifically to those functions, you can ignore for the time limit. Or if you want, you can check it out that how it is happening. Okay. X norm, Y norm. Now there is a correlation function. So just it is COR of X and Y. I think everybody knows what is correlation. It is the relation between the two data sets. I think it is a simple statistical definition. I hope everybody knows correlation is simple relationship between two data sets. That is X and Y, which is here. So next you are plotting it. Now you are giving the points. So it is gray in color. If you want, you can change the color. Next is the bytecode function. See, it is coming here outside. So you can change the points and you can put it within. So how you can, because it is just here correlation coefficient equal to 1. So how you can make it small, anybody? It has become very big. How can you make it small? Anybody?
The CEX value will change by 1 or 2, then it can be small.
Yes. We change it to 2, it will become small. But problem is that it will overwrite. So if it's overwriting, you can go back to the plot function and do it. So plot function, it is making an empty plot. Then you can put gray and the PCH point. Then you can see the correlation coefficient has come properly. Okay. Got everybody?
Yes.
This is how you can change it and you can do it. So one more function I can take for you, substitute function. Tomorrow I will download some data sets, then again we will use the plot functions. Okay, so substitute, as the name signifies, it will substitute some of the expressions. So for situations in which substitution is required with non-genuine mathematical expression such as straight character strings, the substitute function is useful. The code is big, but it is very interesting. You can take it down. And you will understand. You just try to understand line by line, then execute it. Don't worry, the code is big, but it is the expressions which are given here are very small, so no need to worry regarding this. So x value, you are taking it, x, y, then you have n. Ignore the functions here. This is this one regression function it is. So if you want, you can check it out by giving n here. What is it? And ignore the mathematical expressions as I'm telling you here. So you can see here, this is non-linear regression model, data, parent frame, and residual. So try to ignore it because I am not teaching you the statistics here. Just take the function as it is. Don't get yourself confused here. Ignore the mathematical functions. So then you can plot it.
Sir, are you screen sharing the Word document or RStudio?
Oh, sorry. Okay. Okay, so I will come from here. So x and y. Then you have, I gave this n. N, it is like this is the function. What I did here, you can just n is given here. You can just type this n, and you will see that it is a regression model which is created. So for the time being, please ignore the statistics. As I told even the last time when I told correlation, you can ignore the calculations because here I specifically I am just taking the plot functions. I will come again to the specific statistical works when I will take the data sets. So just ignore this line and you can see like what is happening here. It is a non-regression model which is given here. Okay. Next is the plot function. Okay, this is the plot created. So next it is the lines. So you are giving the line here within the plots. Now see here what is happening. A round, B round, C round. So different values are created. So if you want to see the values which is there in the A, B and C, you can check it out. You can see here A is 17.6. It is based on your regression. You can see here A is 17.164. So that is a regression value. So I told you, you can ignore it for the time being. So B is 1.35. Here it is B is 1.35. C is minus 2.02. 04 it will come. Okay, C is minus 2.05. 05 because it should be more than 5. Yeah. 0.2 minus 2.046. That is why it has taken here as minus 2.05 because it is a regression. Next, text function. Text you can understand it. The substitute function is given here for the values. So what is substituted here? You can check it out. So for the A, B, here it is, E is also there, E is given as it is. A is substituted with the value. A is substituted with the value 17.16. E is given as it is. C is substituted with minus 2.05. And B is substituted with the value 1.35 in this particular line. Can you all get it?
Yes.
Yes, sir.
This line you can see here the substitute y equal to A. Then this is the all substitutes are happening. What is the value of A? It is 17.16. It is taken here 17.16. B value which is taken 1.35. It is 1.35 into this is B A minus B. A minus B. Then it is into E value. Then square. That is the square function. That is up function. Then it is you have E. And you have the x value is given into x, and then you have list function, that is the nutrient uptake. Then you have A is given as A equal to A, B equal to B, C equal to C and X is given as time. So here X is given as time. So that is what is the function it is telling here. Got it? How you can include the substitute function. Okay. So next it is mtext. I think everybody knows what is mtext. So mtext, it has given the time here, and below one more mtext is there. You can see here nutrient uptake. So mtext time is in minutes, and mtext expression, it is nutrient uptake mu, that is mu is given here, mu mole per gram at line 3. Got it, everybody? Though the code is big, but it is interesting if you are going through it line by line. So I will not confuse you any further. Please rerun all these codes with different parameters. Okay, please forget the mathematical or the statistical complexes which is happening. Please concentrate only on the functions. Is it fine for you all?
Yes, sir.
Though I know, understand the class was little difficult today, but if you are practicing the codes again, it will be easy for you, because it is given in very simple manner. Because in the subsidy classes, all these codes only will become doubly difficult. So please do it and understand it by giving different values and see what is the changes happening. Okay, everybody?
Yes, sir.
So I want one word to everybody to do it. Please do the homework. Please try to read the data set which was generated in your R. Everybody, except Chinmay. Chinmay has already done it with some other R code, that is okay. Others, please do it. Because from the next class onwards, you have to do the same things. And after this, R plots is over. Each and every time you have to read the R, this one data sets from the Excel or any other, usually from the Excel, and you have to execute it. So everybody, please do it. That is the homework. Please complete, everybody. Some of you have just read the data sets within the R console only. But I want that you read it from the Excel file. Okay?
Okay, sir.
Yeah. Okay, then. Thank you. See you all. Any doubts anybody is having? We will continue this R plots again tomorrow with the by taking the data sets from the taking the data set from the Excel sheet. Okay, thank you. Do you want me to send these codes? Because already I will be sharing with the PPT. You want me to share the codes also separately?
No, sir.
I don't think it is needed, because everything will be there in the PPT which I will be sharing you. Okay then, thank you. See you all. Good night.
Thank you, sir.
Good night,
Nice.
sir.